This is lesson 71, more inverses. In lesson 70, we did the inverses of, we just did a function, we just did a set of ordered pairs, we switched the x and y, and then we did inverses of linear functions, switch the x and y, and solve for y. That's what we're going to do on just a higher level. Let's start with just a basic function like f of x is equal to x squared. Let's do just the classic parabola. That's actually the parent for the parabola. So that's the function. And remember, f of x is my y, so my inverse would occur when my y, so I'll have x is equal to y squared. I need to get y by itself. To get y by itself, I need to take the square root of it. And I get y is equal to the square root of x. And then when we write that as in function notation, I have the inverse of f of x is equal to the square root of x. Number 2. Let's do f of x is equal to something we don't even know what it looks like. And we know it's a function. I'm going to change that to a different letter. Let's do g of x this time. And let's do the fifth root of x. Okay, we could graph it, see what it is. It is a function. You plug in your x's, you take the fifth root of them, one answer. So pretty simple to know with the notation. We know it's a function. So to find the inverse, this is my y. So we're going to switch the x and y. So we have x is equal to the fifth root of y. Now I need to get y by itself. Y equals. Well, to get rid of fifth root, then I need to raise it to the fifth power. Just like if you have square root, you square it to get rid of the square root. So fifth root, and that's, if you remember, the fifth root of y is the same thing as y to the 1/5. And if we have time, I want to try to maybe do a lesson on more details on rational exponents. We'll just have to play that out over the next 2 weeks. And then to get rid of that, I'm going to raise it to 1/5 to the 5th. And then when I multiply the exponents, power of a power, then I'll get y to the 1. So if I raise that to the 5th power, I raise this one, and I get x to the 5th is equal to y. Turn it around, I'll have y equals x to the 5th, or the inverse of g of x is equal to x to the 5th. Okay. Number 3. This actually is a hyperbola. Let's do h of x is equal to 4 over x minus 1. So that's a pretty basic hyperbola. And this is my y. So the inverse, I'm going to switch my y and my x. So I'll have x is equal to 4 over y minus 1. Easiest way to get y by itself, I'm going to add 1. I get x plus 1 is equal to 4 over y. And probably in this case, the easiest to me when I have a fraction, in this case, easily make it a fraction, I'm just going to cross multiply. So I'll have, now notice what I'm going to do. I'm going to write y times x plus 1 is equal to 1 times 4. I'm not going to distribute that, because if I do, I'm going to have xy plus y. And remember, I'm trying to get y by itself. So I'm just going to leave it like this. And to get y by itself, I need to divide by the x plus 1. And I'm going to put it in parentheses. That makes it easy to divide by it. And divide by it on both sides. So x plus 1's gone. I have y is equal to 4 over x plus 1. So the inverse of h of x is 4 over x plus 1, which is actually another hyperbola. Okay, let's do just a classic parabola. We did a parabola in number 1. It was the parent, but let's do f of x is equal to x minus 2, parentheses, I said quadratic. It's actually a cubic. So when I just looked over there, I was thinking it had a squared. It actually has a cube. So it's a cubic function. We'd have to look at the graph to know exactly what it's doing. If you remember, they're S-shaped, leading coefficient's 1, but we're not even interested at this point. It is a function, and we need to find its inverse. So this is my y. There's my x. I'm going to switch some inverse. So I have x is equal to y minus 2 cubed minus 3. Now, it's like a Christmas package. You're going to have to, that's been wrapped in a couple of boxes. We're going to have to get this by itself, we're going to have to get rid of the minus 2, the cube, and the minus 3. But order of operation, you got to go to the outside first. We're going to have to get rid of this, then the cube, then the 2. So let's add the 3. And we get x plus 3 is equal to y minus 2 cubed. Okay. We need to get rid of the cubed. So to do that, we need to take the cube root of it. So we have cube root of x plus 3, and that looks like 3 times. I need to do a better job of that. Of x plus 3 is equal to y minus 2. See, those got rid of those. And then I can add the 2. And that's a little messy looking, but I have y is equal to the cube root of x plus 3, and then plus the 2. See how it was set up? You just kind of had to work your way backwards. So the inverse of f of x is equal to this, cube root of x plus 3, and then plus 2. Okay, one more. Number 4. Is that right? Oh, actually, this was number 4, and this was number 5. I was thinking I had 5 examples. I have h of x is equal to the cube root, now look at this, of x plus 4 over 2. Okay, and the cube root is over the whole thing. This is my y. So I'm going to switch and have x is equal to the cube root, big cube root, of y plus 4 over 2. Now, look at what we have to get rid of first, and what we have to get rid of, and what order you have to do it to get this by itself. Well, we're going to have to get rid of the cube root, the outside package. Then we'll get rid of the 2, and then we'll get rid of the 4. So let's go ahead and raise both sides to the third power. We'll get x cubed is equal to y plus 4 over 2. You can cross multiply, or you can multiply both sides by 2. It'd be just as easy to probably go ahead and multiply both sides by 2. And I have 2x cubed is equal to y plus 4. Minus 4, we get y is equal to 2x cubed minus 4. So the inverse of h of x is 2x cubed minus 4. The main thing is you just got to be careful with your reverse order of operation.